Hi, good morning. Today we are going to make use of what we learned in chapter 1 to apply to some application problem regarding normal distribution. Now we will learn how to use the CDF, how to use the inverse normal, and we will also learn how are we going to standardize a normal distribution. For that, let's begin. Question 1. Let X be the random variable that represents the height of man in Great Britain. Now, X has a normal distribution with mean 67 and standard deviation 2.5 squared. Now, you are asked to find the probability such that the man's height is between 66 and 68. Now, this sum is really simple. Now, you can key that into your calculator, all right, using the Normal Cdf. Now, if this is not familiar to you, or really it sounds alien to you, now please watch the first video, the first lesson on normal distribution. So you go to your calculator, you choose Normal Cdf, and then lower limit will be 66, upper limit 68, mean will be 67, and standard deviation 2.5. Now, actually what they are looking for is this part of the area. Let's say this is 66, and the normal distribution is symmetrical about its mean. So this will be 67 because the mean is 67. And then the upper limit is 68. So they are looking for this area here. All right, what is this area? So you just need to key this into your calculator and you will have an answer of 0.1151. Okay. Now let's move on to question 2. In question 2, you are asked to find the probability that X is greater than 70. That means the height of man to be greater than 70 inches. This is 68. So let's say this is 70. Now same thing. You will use your normal CDF to find this area here. So your lower limit is 70, upper limit you can key in 9999. You want to put more 9s if you want. Now mean is 67, standard deviation 2.5. And then you will get the answer of 0.3108. Okay? Now let's move on to part 3. In part 3, you are asked to find the probability of X is within one standard deviation of its mean. Now, within one standard deviation of its mean means what? Now, let's say this is the normal distribution of X, or probability density function of X. This is 67. Within one standard deviation, that means here will be 67 minus 1 sigma. Sigma is 2.5. So you get 67 minus 2.5, you get 64.5. And one standard deviation away, so this is also 1 SD. So this will be 69.5. This is 67 plus 1 SD. Okay, so they are asking for this area here. That is the probability. So all you need to do is, same thing, you use your normal CDF. lower limit 64.5, upper limit 69.5, mean 67, standard deviation 2.5, and then you get an answer of 0.6827. This is your answer to part 3 of the question. Now, the last part of the question, now they ask you to determine the 95th percentile of X. Now, how to find the 95 percentile of X? Now, that means they want the value of X. Let me use a different color. They want the value of X, all right? Let's say this is the value of X, all right? This is the value of X. Now, they want this value of X such that 95% of the people fall below this height, okay? All right, this will be now this will be 0.95. All right, this area here, okay, to the right of X. Now, so how to find X? Now, you learned in the earlier chapter, you can find X if you have this area, you have the mean, and you have standard deviation by using the inverse normal. So this one you can just use inverse normal. All right. What's the area? The area is 0.95. Mean is 67. Standard deviation 2.5. And this is on the left. What is your answer? Input this into the calculator, you will get an answer of 71.12. So X will be equals to 71.12. Now with that, let's move on to question 2. Question 2. Now, let X be the random variable that represents the resistance of resistors being produced. Now, it is stated that in the question that X is normally distributed with a mean of 80 and a variance of 0.4. Now, the resistors are accepted if the resistance measured is between 79 and 81. Now you are to find the expected number of rejects in a batch of 1000. Now, what we can do is we find the probability that the resistors is being rejected, and we just multiply by this 1000. Then we will get the expected number of rejects. So let us show you by representing it graphic in a diagram. Say this is the mean 70 or 80 and a variance of 0.4. So this is 81 and this is 79. Now the rejection, the probability that is being rejected is represented by this shaded area in pink. Now, so how to find this probability? Now we can do it by finding this region that is not shaded, and we 1 minus that region will give us the probability of the shaded region. So let's do that. Probability that is between 79 and 81. Now, if you key that into the calculator, all right, lower limit 79, upper limit 81, mean 0.4, standard deviation square root. I say again, is square root of 0.4, not 0.4, all right. And for that, you will get an answer of 0.886153. Now, this is the probability that it is being accepted. All right, so the probability of being rejected, all right, is just 1 minus 0.8862. Let's say. Now, so expected number of reject. So the expected number of rejects will be 1000 multiplied by 1 minus 0.8862. Okay. And for that, you will get an answer of 113.85. Okay. Now let's move on to part 2 of the question. Now sigma is being adjusted, but mu is unchanged. You are asked to find sigma max if on the average at most 4 is rejected. Now the criteria of rejection is still unchanged. It's still between 79 and 81. But you find that you can't use the calculator now because you do not know the standard deviation. The parameters for a normal distribution is mu, that is the mean, and the standard deviation. Now we lack the information of the standard deviation. So there's no way that you can use the calculator. But what we can do is we can convert this to a standard normal. A standard normal is a normal distribution that has a mean of 0 and a standard deviation of 1. Now, so what is the corresponding point of 81 on a standard normal distribution? Then you need to apply this formula. Z will be equals to x minus mu over sigma. Now, Z is the value here, all right? X is the value, the original value. All right. Now, so what is this value of 81? This value 81 will then be, now 81 minus 80. So I will get 1 over sigma. And what is this value here? For 79, it will be 79 minus 80 over sigma. So it will be minus 1 over sigma. Now the probability of rejection, all right, is given by 4 out of 1000. So this area here plus this area here, all right, is 4 out of 1000. Okay, but these two being symmetrical, that means this side will be 0.002 and this side will be 0.002 as well. Okay. Now, this has a distribution of mean 0 and standard deviation 1. Now, you know that this area is 0.02. So what you can do is you can input this into the calculator, all right, using the inverse normal. So you put inverse normal. The area is 0.002 with a mean of 0, standard deviation 1. The area is on the left. Okay, and that gives you an answer of minus 2.878. All right. Now, so this is minus 2.878. So minus 1 over sigma will be equals to minus 2.878. Then you just key into the calculator. You will find that sigma is equals to 0.3474. Okay. Hi. In question 3, you are given that in a particular workshop, the mass of the objects that it produces has a normal distribution with mean mu and standard deviation sigma. Now, it is also given that the probability of X, alright, the object that is produced, when it's for less than 25 gram is 0.1. Now, and the probability that the object is greater than 85 gram is 0.05. You are asked to find mu and sigma. That is the mean and its standard deviation. Now, when you do not know its mean or its standard deviation, what we must do is we need to convert it to a standard normal distribution. Now, a standard normal distribution has a mean of 0 and standard deviation 1. Now, because if we do not have one of these, its mean or its standard deviation of the actual population, then you find that you cannot use the calculator to help you because they will always prompt you for mu and sigma. So we have no choice, we need to convert it to a standard normal distribution. Now let me draw this portion of it and see what does it mean. Now the probability that X is smaller than 25 gram is 0.1. So this part is 0.1 and this is 25 gram. Alright, that is greater than 85 gram. So let's say 85 gram is here. Greater than 85 gram will be to the left of 85. Alright, and this was 0.05 and this is 85 gram. Now we need to convert this to a standard normal. So what is this point on the standard normal graph? You need to undergo a transformation, and the formula for the transformation is Z is equals to X minus mu divided by sigma. X is the data from the actual population. Z is its corresponding value on the standard normal graph. So what is this value here? This value will be given by 85 minus mu over sigma. Likewise for the 25 gram. This one will be 25 minus mu over sigma. And you find that this area here is 0.05 and this is 0.1. Now that we have the mean and the standard deviation, we can use our graphical calculator to help us. So we need to find the corresponding point for this in a normal distribution. So how do you do that? Now you can do an inverse normal. So inverse normal of 0.1, that's the area, followed by the mean and the variance, and you must indicate in the calculator that it is on the left hand side of the graph. So it's left, and that you get the value of minus 1.281. Now 1.281 correspond to this particular point on the standard normal graph. So you get what minus 1.281 is equals to 25 minus the mean over the standard deviation. Okay. Now the next thing we need to do the likewise for this point. All right, we can do a inverse normal 0.05, and then but this point the area here you must indicate to the right instead of the left, because this is to the on the right hand side of the bell-shaped curve. Now I leave that to you, and you find that this the answer you get will be 1.644. all right, so you got 1.644, and this point correspond to 85 minus mu over sigma. Now, so let's call this equation 1 and this equation 2. Now, so you can go ahead to solve this simultaneous equation, and you will get the value of mu to be 51.3 and sigma to be 20.5. Next, let us find the range symmetrical about its mean within which 75% of the masses lies. Now, what does this mean? Now, just now we find that the mean is 51.3 and the standard deviation is 20.5. So you want the range symmetrical about its mean, all right? So symmetrical about its mean, where 75% of the masses lies. That means this area here will be 0.75. Now, since it is symmetrical, so this area A will be equals to area B. Now, what is the area A? Area A will be simply 1 minus 0.75, which is 0.25, divided by 2. So this area here will be 0.125. Since it's symmetrical, so is this area 0.125. Now they are asking for these two values. All right, maybe I put it P and this value Q. All right, and X must lie between P and Q, so that this is 0.75. So how are we going to find the value of P and Q? Now, very simple, since we know its mean and standard deviation, and we know the area, we can use the inverse normal. All right. So for this point P, all right, for point P, you simply use inverse normal. Now the area is 0.125, mean is 51.3, standard deviation is 20.5, and the area is on the left hand side of the curve. And you will get the answer of 27.71. Now, what is Q then? Now, so how to find Q? Same thing, all right? So for Q, we simply key in the same thing, all right? So, but instead of left, we put right, because this area is also 0.125, and the mean is, we're talking about the same distribution curve. So the mean and the standard deviation will also be the same, except that this is, instead of left, it will be right. And then you will get the value of Q as 74.88. So what is the range of value about mu? So the range of value will be x to be greater than 27.71 but smaller than 74.88. Okay. For that, we have completed all the 3 questions. Now we will be ongoing producing a lot of videos on various topics. Keep a lookout, and if you like our video and you are learning something from it, please press the subscribe button. Thank you for watching and have a nice day.